In this video, we're going to talk about the APCalculus AB 2007 FRQ number 2. This is a classic FRQ problem type. You're given a rate at which something is going in or increasing, and then a separate rate at which something is exiting or leaving or going out or decreasing. And you kind of have to balance those two rates. And often in a question like this, which happens here, they'll start with just how many gallons, how many people, how many whatever go in, how many enter the tank. So I only care about this first rate of change here, which is the rate at which water enters. Question A has nothing to do with the leaving. So question A, if I have the rate and I want to know how many, that's what we call the net change, and I need the definite integral. So that for part A is the definite integral from 0 to 7 of, I'm just going to write f of t dt. And that's all you would need to do to show your work on the AP exam. This is a calculator allowed question, so type it in to your calculator. Now obviously you can't type f of t into your calculator, you have to type the actual function in. But when you do that, you get about 8,264. They want this problem rounded to the nearest gallon. That's a 264. So that's how many gallons of water enter the tank in the first 7 hours. That's all we need to show. One little note, College Board questions always in terms of radians, not degrees. So make sure you are in radians, not degrees. Part B, time intervals during which the amount of water is decreasing. Well, the water is going to be decreasing anytime that the rate out is more than the rate in. And we can see that happening a couple times on our graph here. The rate out is this piecewise horizontal function. And so we've got this chunk here where the rate out is greater. And then we've got this chunk here where the rate out is greater. So right here at 3, we kind of switch. And then at this value here and this value here, we switch. So the rate out should be greater. We're decreasing from 0 to that first intersection point, which they tell us is 1.617, and then also from 3 to the next intersection point, which is 5.076. And that again is just because the amount of water, I'll write it out this time, the amount of water is decreasing if g of t is greater than f of t. That's all we need to say there, I think. Now part C, at what time t is the amount of water in the tank the greatest? So we're looking for a maximum here. And so we know that a maximum can only occur at a critical number or where or at an endpoint. And in terms of critical numbers, we can be a little bit more precise. A critical number being where the rate of change is either 0 or undefined. But that can result in either a maximum or a minimum. The maximum can only happen if the derivative is changing from a positive derivative to a negative derivative, if the function is changing from increasing to decreasing. And so we just said that at these times here, 0.617, or from 0 to 1.617, the function is decreasing. And then from 3 to 5.076, we're again decreasing. So that leaves this interval here where we're increasing from 1.617 to 3. where we are increasing. And then from 5.076 to 7, where we're again increasing. So there's really 3 values that I have to check here. I need to figure out, I'm going to say that W is the amount of water. I need to know what is W of 0, what is W of 3, and what is W of 7. Those are the only places that the maximum could occur. W of 0 is given to me as 5,000. W of 3 I'm going to find by doing that initial amount, 5,000 plus the integral from 0 to 3 of f of t, scroll over a little bit here, see if we can get some more room, of f of t minus g of t. Now, because g of t is just 250 at this point, you could actually just say, I'm going to write in obviously just 250, or you could actually just put that outside of the definite integral and say, well, 250 for 3 hours, I know how many gallons we're subtracting. But keeping it inside the integral will achieve the same thing. If I do that, I'm going to give myself a little more room here again. If I do that simplification, we will get 5,126.591. So just a little bit more than what we started with. Now we do the same thing for W of 7, and that's going to be that amount that we just left off with plus the definite integral from 3 to 7 of f of t minus g of t dt. Here we had to change this initial value. This was 5,000 because that's how much you started with at 0. Now because we're going from 3 to 7, I need this as the initial value, what I had at 3. And then I add those things up, and I'm going to get 4,513.807. And we round that to the nearest gallon, or our final answer anyway, to the nearest gallon. So this is the one that's the biggest here after 3. Rounded to the nearest gallon, our final answer is 5,127 gallons. And so that's the maximum amount of water, and that occurs at time t equals 3. Let's see, did they ask for a justification? Yes, so they wanted a justification here. Now, the justification is that this is the place, t equals 3, is where the derivative change, where the amount of water changes from increasing to decreasing. And so these are the 3 possible candidates. What did we start with? What did we have when we changed from increasing to decreasing? And then what did we have at the end because we were increasing again there? But this is the biggest of those. So, yeah, that is 2007, number 2.